There's a desert where the wind moves sand so fast that a seedling planted today might be buried, gone, or blown 20 feet away by tomorrow. And yet, in the middle of that same sand, China has built green belts that now stretch for thousands of kilometers. At first, the answer seems obvious. Plant trees, more trees, greener desert. Simple math. But that assumption is the biggest misunderstanding in this entire story. Because the real enemy in a desert isn't a shortage of trees. It's sand that refuses to stay still. Until that sand is stopped, no forest, no matter how carefully planted, is going to survive there. This is where China's approach gets strange. They didn't start with forests. They started with dry straw. Picture thousands of kilometers of nothing but sand. No water, no shade, no stable ground to root anything into. Instead of planting trees into that sand, workers pushed dried wheat and rice stalks into the earth, weaving them into small squares, a grid across the dunes. At a glance, it looks like something a child built for a game. But this simple lattice quietly rewrites the physics of wind. It's called a straw checkerboard. Dry stalks get pressed into the sand in a grid pattern, part buried, part exposed above the surface. When fast wind sweeps across that surface, its speed and direction change right at ground level. Sand can no longer lift off as easily. New sand carried in by the wind gets trapped inside these small squares instead of moving on. In other words, China didn't try to defeat the desert head-on. They slowed it down first. That single shift changes everything downstream. Once sand stops moving, the next step becomes possible. Plants. Except even here, the story isn't as simple as it sounds. Drop thousands of saplings into stabilized sand and walk away, and the desert will quickly remind you how precious water actually is. Some early efforts planted species that weren't suited to such an arid climate. In certain areas, deep-rooted, thirsty trees ended up pulling hard on local groundwater, solving one problem while creating another. So China had to learn a second lesson. Greening a desert was never about planting the most trees. It was about planting the right plant in the right place. That's why modern restoration projects lean heavily on native, drought-resistant shrubs and grasses instead of whatever grows fastest. Think of the whole process as a staircase. Step 1. Stop the sand. Step 2. Stabilize the soil. Step 3. Establish vegetation that can survive on very little water. Step 4. Make that vegetation stable enough that the next generation of plants can spread on its own. This is where the real engineering begins. A desert doesn't get greened in a single construction phase. It's a feedback loop that runs for decades. Sand stabilizes a little. Vegetation moves in. That vegetation locks the soil down further. Soil starts holding more moisture, and conditions for the next wave of plant life get slightly better than before. One small shift enables the next. Given enough time, that chain reaction can reshape an entire landscape. But this isn't only the story of the Kubuqi Desert. Behind it sits a far bigger national effort, the Three-North Shelterbelt Forest Program. Launched in 1978, it set out to control desertification and wind erosion across China's north, northeast, and northwest. Nearly half a century in, the program has involved planting billions of trees. Yet the number of trees isn't actually the most interesting part. The scale is. This isn't one forest you're looking at, it's an ecological defense system attempting to reshape entire regions. And that scale creates a new problem of its own. If you're building a green belt thousands of kilometers long, who maintains it? Who plants the next round? Who repairs straw barriers after a storm? Who manages the irrigation? Who decides which species can actually survive in which stretch of land? Nature isn't a factory. You can't press a button and expect a guaranteed result. So in places like Kubuqi, a different model emerged, one linking government programs, local communities, and private investment together. The idea behind it was simple. If greening the land also improved people's livelihoods, restoration was far more likely to last. Then the story takes a turn few would expect. Land once treated as a pure liability started hosting something new, solar panels. On and around the stabilized sandy ground of Kubuqi, solar farms began going up. Suddenly, the same land was doing two jobs at once. Above ground, panels were generating electricity. Below them, shade was reducing water evaporation in parts of the site, creating a slightly better microenvironment for vegetation to take hold. A machine built purely to generate power was quietly reshaping the conditions for ecological recovery. the desert stopped being just a power source. It became a laboratory, sitting between infrastructure and ecology. It would be easy to end the story right here. China planted trees, the desert turned green. Problem solved. But real engineering stories rarely end that cleanly, because behind every major success, there's usually a failure that shaped it. China's desertification campaign had its share. Some early afforestation choices used species poorly matched to local conditions. Survival rates in certain areas were disappointing. In some cases, water demand from the new plantings became an ecological strain rather than a relief. That produced an important lesson. Turning desert into forest was never the actual goal. The real goal was building an ecosystem that could survive on the climate's own terms. Which is why the language around restoration has shifted. It's no longer just trees planted. It's soil stabilization, water conservation, native vegetation, wind control, grazing management, and long-term monitoring. This isn't gardening, it's landscape engineering. If stories like this, where the real breakthrough looks nothing like what you'd expect at first glance, are the kind of thing you want more of, subscribe, because the next one goes even deeper. Because there's still a bigger question we haven't touched. Is greening a desert always automatically good? That question sounds strange at first, but it matters. Push vegetation into the wrong place at the wrong scale, and the very thing meant to stop desertification can make water scarcity worse instead of better. This is the point where China's story stops being a pure success story. It becomes a warning, too. Satellite data does show human-led greening across many Chinese dryland regions. Research on Kubuqi links a large share of its vegetation recovery directly to human intervention. But climate patterns and rainfall shifts play a role as well. Not every green patch on the map is purely a human achievement. Not every planted tree is proof by itself that something worked. Which is probably why China's biggest lesson isn't you can plant trees in a desert. Everyone already knew that. The real lesson is this. Change the physics that's killing the plant before you plant it. Slow the wind. Trap the sand. Stabilize the soil. Save the water. Then bring in vegetation built to survive that specific environment. Tie all of that to local economies, solar energy, and decades of ongoing management, and land once written off as wasteland can slowly become something else entirely. But the story doesn't stop at China's borders. China didn't keep this technique to itself. Low-tech tools like straw checkerboards are now being studied and applied in other dryland regions around the world. The real question isn't whether China can green a desert anymore. It's whether this model can survive contact with the world's harshest deserts elsewhere. And if the answer is yes, the next battlefield won't be a desert in China. It'll be the millions of hectares of land turning back into sand somewhere else every single year. And there, planting trees alone almost certainly won't be enough.